Hi guys, my name is Harry. In this tutorial lesson, we're going to find a solution to a non-homogeneous linear second order differential equation. The question is given as follows. Find the general solution of y second derivative minus 3y first derivative plus 2y is equals to 1 over 1 plus e to the power minus x. Given that our first solution, y1 of x is equals to e to the power 2x, is a solution of the complementary equation y second derivative minus 3y derivative plus 2y is equals to 0. We can notice that we have a linear second order differential equation which is non-homogeneous, and by principle we can apply the method of variation of parameters directly by finding the complementary solution that contains both the two solutions y1 of x and y2 of x, and then continue and find a particular solution in order for us to determine the general solution to this non-homogeneous linear second order differential equation. But in this case, we are given the first solution y1 of x to be equals to e to the power 2 of x. So as a result, we need to use the method of reduction of order in order to find the general solution to this given nonlinear second order differential equation. You'll notice that even when you use the method of variation of parameters directly without considering the first solutions and that is given, you would still get the same answer. But now, due to the fact that we are being given the initial the first solution, we have to use the method of reduction of order. So by the method of reduction of order, we firstly assume that our general solution y of x is in the form of u of x multiplied by y1 of x. And so this is then going to be equals to u multiplied by y1 of x, which is e to the power 2x. Then from here, we're going to find the first derivative of y of x, which is going to be given by u prime e to the power 2x plus 2u e to the power 2x. And then the second derivative, it's then going to be equals to u double prime e to the power 2x plus 2u prime e to the power x plus plus 2u prime e to the power 2x plus, this is going to be 2 times 2, which is 4u e to the power 2x. Then the y double prime of x is then going to be equals to u double prime e to the power 2x. These are like terms, so this will be 4 plus 4u prime e to the power 2x, then plus 4u e to the power 2x. Now let's now substitute our y of x, y prime of x, and y second derivative of x into our given non-homogeneous linear second order differential equation, which is y double prime minus 3y prime plus 2y is equals to 1 over 1 plus e to the power minus x. So firstly, we have y prime. We know that from our assumption that our solution it's given, it's in the form of u y1 of x. Our y double prime is, now let's do the substitution. our y double prime is u double prime e to the power 2x, then plus u plus 4u prime e to the power 2x, then plus 4u e to the power 2x. Then this is minus 3 multiplied by y prime, which is u prime e to the power 2x plus 2u e to the power 2x. And then this is going to be plus 2y, which is u e to the power 2x. Then this is equals to our f of x, which is 1 over 1 plus e to the power minus x plus e to the power minus x. Then we're gonna simplify further. So we have u prime e to the power 2x plus this is going to be, we have like terms, this, and then minus 3 multiplied by this. So this is going to be 4 minus 3, which is 1 u prime e to the power 2x, and then we have plus 4u e to the power 2x, and then minus 3 multiplied by 2, this will be minus 6u e to the power 2x, and then plus 2u e to the power 2x. This is all equals to 1 over 1 plus e to the power minus x. Then from here, we can notice that for u, when we take minus 6u to the power 2x plus 2u e to the power 2x, we get minus 4u to the power minus 4u e to the power 2x. So that will be 4u e to the power 2x minus 4u e to the power 2x, which is 0. Therefore, the resulting equation will be u double prime e to the power 2x plus u prime e to the power 2x. It's equals to 1 over 1 plus e to the power minus x. Now we can then divide everything by e to the power 2x, and then we're gonna get that. Let me open another page. So we're gonna get that u double prime plus u prime is equals to 1 over 1 plus e to the power minus x multiplied by e to the power 2x. Then from here, we have to reduce this equation to a linear form. So we're gonna we have to reduce this equation to a first order linear differential equation. So we're gonna let z to be equals to u prime, hence z prime. Hence z prime will be equals to u double prime. Thus, our new differential equation will be z prime plus z, it's equals to 1 over 1 plus e to the power minus x, this, and then multiplied by e to the power 2x. So then from here, we have to find the solution to this linear first order differential equation. As we can see, we have a linear first order differential equation which is non-homogeneous. So we continue by finding the integrating factor. So the integrating factor, it's going to be given by e to the power integral. What is the value of px? It's simply 1, then dx. Therefore, the integrating factor will be e to the power x. Now, therefore, the general solution for this linear ODE, that is z of x, it's going to be given by 1 over the integrating factor multiplied by the integral of the integrating factor minus the integral of the integrating factor multiplied by f of x, and our f of x is 1 over 1 plus e to the power minus x, and then e to the power 2x, e to the power 2x, and then the line integral of integrating factor multiplied by f of x, and then dx, and then plus, we can call this C1, the constant C1. Therefore, this is going to be equals to 1 over e to the power x into the integration of 1 over 1 plus e to the power minus x. And then we can notice that when we multiply e to the power x by 1 over e to the power 2x, we are left with 1 over e to the power x. And then dx, and then this is added to the constant C1. Then we're going to integrate this by using the u substitution. So we're going to let u to be equals to 1 plus e to the power minus x. Therefore, our du will be given by minus x to the power minus x dx. As a result, dx will be given by minus 1 over e to the power minus x du. Now let's substitute. That means the z of x will be given by 1 over e to the power x, then into the integral of 1 over u multiplied by 1 over e to the power x multiplied by our dx. So this will be multiplied by our dx, which is minus 1 over e to the power minus x, e to the power minus x. Let me erase this and rewrite it again, e to the power minus x du. Then this is plus C1. And then from here, we're gonna get that the z of x is equals to 1 over e to the power x. Then into, we can notice that we have e to the power x and e to the power minus x, which is going to be e to the power 0. So 1 over 1 is 1. Therefore, we're going to have this to be minus the line integral of 1 over u du. And this is added to the constant term C1. And then this is added to the constant term C1. Therefore, the z of x is then going to be equals to 1 over e to the power x, then into minus the ln of u, the integral of 1 over u, right? Then plus c1. Thus, the z of x is then equals to minus the ln of, we did let u to be equals to 1 plus e to the power minus x. Then this will be divided by e to the power x. Then this is plus c1 divided by e to the power x. So remember, previously, in order to reduce this equation to a first order, we did let, sorry about that, we did let z to be equals to u prime. Hence, we can conclude that the u prime, we can conclude that the u prime of x is equals to minus the ln of 1 plus e to the power minus x, and then divided by e to the power x, then plus c1 over e to the power x. And then from here, we can then find our u by integration, right? We know that u prime of x can be written as du over dx. Then this is equals to minus the ln of 1 plus e to the power minus x over e to the power x plus c1 over e to the power x. Then from here, a separation by variables, du will be equals to minus the ln into 1 plus e to the power minus x divided by e to the power x plus c1 over e to the power x. And then we multiply this whole thing by dx. Now we're going to integrate both sides of the equation. We're going to integrate both sides of the equation. Therefore, this side we're going to have u of x to be equals to minus the integral of ln of 1 plus e to the power minus x, close bracket, divided by e to the power x dx, and then this is plus c by the integral of 1 over e to the power x dx. So this is equals to, for the first term, the integral of ln of 1 plus e to the power x divided by e to the power x. We're going to use the u substitution. We're going to let u to be equals to 1 plus e to the power x. Therefore, du will be equals to minus e to the power minus x dx. Hence, dx will be equals to minus 1 over e to the power minus x du. So let's go and do our substitution. Let's do the substitution. Now we have u of x. Now we have u of x to be equals to minus, right, the line integral of ln of u, and then we divide this by e to the power x, and then we're going to multiply this by the new dx, which is So I'm gonna write it below. This is multiplied by the new dx, which is minus 1 over e to the power minus x, e minus 1 over e to the power minus x du. And then this is added to the constant c multiplied by the integral of 1 over e to the power x dx, right? Therefore, we have u of x to be equals to negative, and the negative makes it a positive, so we're simply going to have the integral of ln of u. And then we can notice that this and this will be e to the power 0, which is simply 1. So this is simply the integral of ln of u du, and then plus plus c by the integral of this thing. I can rewrite it as e to the power x. So the u of x is then going to be equals to the integral of ln of u. When you use integration by part, you're gonna get that the integral of ln of u is u multiplied by the ln of u minus u. So this will be plus the constant c multiplied by the integral of e to the power x, that is minus e to the power minus x, close bracket, and then we're gonna add our constant c2. And then also remember that this is constant c1. I've been writing it as just c. This is c1. This is constant c1. Even here, this is c1. Now plus c2. Then from here, we can then substitute our u. We did let u to be equals to 1 plus e to the power minus x. Therefore, the u of x, therefore, the u of x is then going to be given by 1 plus e to the power minus x multiplied by the ln of 1 plus e to the power minus x, and then minus u, which is, then this is minus u, which is 1 plus e to the power minus x. Then this is minus c1 e to the power minus x plus c2, right? So this is u of x. Therefore, remember we said that we assumed that the general solution is in the form of u of x multiplied by y1. We found our u of x. So we can substitute it there and multiplied by y1 of x. So hence the general solution to the ODE will be y of x, which is equals to u of x. And we found u of x to be 1 plus e to the power minus x, which is multiplied by the ln, which is multiplied by the ln of 1 plus e to the power minus x, and then this will be minus, we can see that we're going to have minus 1 when we take this minus to multiply by this, then minus e to the power minus x, and then also we have minus c1 e to the power minus x plus c2 close bracket. So we multiply this whole thing by y1, and our y1, it's e to the power 2x, e to the power 2x. Therefore, the general solution we can simplify by multiplying e to the power 2x by every term that is inside the brackets. Therefore, the y of x is then going to be equals to, check this, when I multiply, let me use a different color. Now let's say y of x. When we multiply this by 1, we get e to the power 2x, which we then multiply by this, by ln of 1 plus e to the power minus x. And then we take this again, we multiply it by e to the power minus x. That will give us plus e to the power x, which we then multiply by the ln of 1 plus e to the power minus x, close bracket, and then we take e to the power 2x again, we multiply it by minus 1, so this will be minus e to the power 2x. We take it again, we multiply it by minus e to the power minus x, so this will be minus e to the power x. And then lastly, we're gonna take the same value, and then we multiply it by this. So we're gonna have minus c1 e to the power minus x plus 2x, which is simply x, And then lastly, we're gonna take the same value, and then we multiply it by x squared. So this will be plus c2 e to the power 2x. So, and this will be the general solution. You will notice that even when you use the method of variation of parameters, you're gonna get the same solution as this solution that we got using the method of reduction of order. So we can also rewrite this thing in a in a perfect format, right? By saying that the y, which is the general solution, is equals to, it's equals to okay. Let me double check something here. Okay, perfect. So this is going to be y of c. Then we can rewrite this as c2 and minus c1 e to the power x, and then plus e to the power 2x plus e to the power 2x ln of 1 plus e to the power minus x, and then plus e to the power x by the ln of 1 plus e to the power minus x, e to the power minus x, and then minus e to the power 2x minus e to the power x. So from this solution, we notice that this is the general solution, right? Using the reduction of order method. So we can notice that if we were to use the variation of parameters method, we would notice that basically there's a solution here in terms of the constant C1 and C2 is what is the particular solution. Is the particular solution, I mean, not the particular solution, is the complementary solution, which is the solution to the homogeneous equation. And then there's a solution here is the particular solution. And we know that by definition, our general solution is the complementary solution plus the particular solution. And that's what we're going to get by using the method of variation of parameters. So each method is convenient under certain conditions, but in this case, method of variation of parameters will be more convenient as we don't have to perform a lot of integration. But this is how we approach the question using the reduction of order method. Thank you.